Okay, let's continue with call by name. So this is a form, like I said before, of lazy evaluation. In call by value, you evaluate the argument as soon as you see the call. You look at the argument, you evaluate it at that time. In lazy evaluation, you wait until it's actually encountered in the evaluation of the body during the call. So here's the declaration point. The only thing that's different is that this has name instead of var or nothing. So that's identical. So when we call a call by name procedure P with a expression A, this rule is the simplest of all, apparently. It basically says, look, when you see the call for P, look up P in the current environment for procedures. You get back the body, the formal parameter, the environment that was used, the variable environment used at the time of the declaration of P, the procedure environment in place at the time of the declaration of P, and you simply use those. You don't have to modify them in any way. And then what you do is you take the body, and this notation here is notation for what's called capture avoiding substitution. It says, take the body S, and every time you see an X, replace it with the A expression A, which is the parameter here. So this rule is really very, very simple. But, well, the crux of the thing is that this notation here, S with X, it looks like our point-wise environment update or the store update. It looks like a point-wise function update, but it actually is replace all the free X's in S by A. Other times I've used notation that looks like this, X colon equals A. Or sometimes you see, this is substitution notation. Or sometimes you see, I think, S, and I can never, A for X. Oh, maybe without even the square brackets, just round brackets is a common notation. A for X. He uses this one over here, which is S, X, A. Now, I just looked. I mean, I haven't given much I haven't really given you any information here. He goes on about the substitution, defining in section 7.5.4. And so let's see, for details. For details, see section 7.5.4, which starts on page 104. And then it goes on and on and on and on to page 110. So, it's 6 pages in this rather dense book. The thing is that this is tricky. The code is tricky. I've implemented it in Haskell, and I just looked at it, and I think it's about 110 lines long, whereas all the other code for the environment, for the big step semantics, including all 3 different call by mechanisms, is 200 lines long. So it's it's tedious and a long piece of code. But all right, so let's just go over this in a step-by-step fashion. The first thing we do is look up P in ENVV. That's the current environment at the time we're seeing the call. That's going to give us the body, the formal parameter, the variable environment that was in place at the time that P was declared, and the procedure environment that was in place at the time that the procedure P was declared. Replace all the free occurrences. Now that's the part that's tricky to define of the variable x in S by the actual parameter A. And so if the result is S prime, then evaluate S prime. Now he doesn't store it in a temporary thing. He just writes this down. He could have written down something down here, like S prime equals S with X colon A. And then he could have just used up here S prime. But I mean, it doesn't save you much, except that you don't, you're not kind of mixing operations, but it's perfectly okay to do that up there. So, and we evaluate S prime in the static. Well, that's the eraser. In the statically using the environments that were in place at the time of the declaration was made. Now, one thing to notice is that, if you're going to, I guess you could always call this simply with a variable, which is an A expression. But if you ever call it with something more complex, the formal parameter X cannot occur on the left side of an assignment. It leaves something like, you've got, suppose I say like, I guess I didn't write it out completely there. Suppose I had like proc P name X equals X gets the value of 7. And then if I say call P with X plus Y, which is perfectly okay because this is an A expression, I'm going to end up with something like this, which is syntactically incorrect. So it's interesting, the author of our book, Huddle, is Danish, and call by name was implemented in Algol 60, and the Algol 60 report was written by Backus and Nauer, and you may have heard of Backus-Nauer form, and it's like when they started trying to figure out how to describe very precisely what the meaning of a programming language is, they realized first they needed a precise way of describing syntax. And so that's why we have BNF, Backus-Nauer form. And it was an international effort. And Huddle is Danish. And somebody named Jorn Jensen, I never knew his first name before, was a Danish programmer at the time, and he figured out an interesting way to use call by name that you can't do unless you have call by name. And so here's a program, and I mean you can see down here, but it's almost invisible, that this program essentially computes the sum of I equals 1 to 10 of I squared. And so the way that it works is you look here and you see, okay, low is 1, and then, so that's our low, and then I starts at low, and our sum is starting out at 0, and then here's a procedure that uses this, and then we call find sum on I times I. So what's going to happen? We're going to get, when we evaluate this thing, look 0, well, maybe let me get something darker. I guess, well, you can see that he's got some syntax errors in his program. This is not a reasonable program. He needs a begin end around this thing. I think he would have been okay, actually. Yeah, his begin is just in the wrong spot. Like this thing here, if this was up here, he'd be okay. He declares his two variables and then he has his code. But in any case, there's a syntax error here. And then this one took me a while to puzzle over. I said, well, what's going on here? Here's a begin end block here with no variable declarations. But you know what? That's perfectly okay because he includes the possibility of having no declarations. So anyway, there are a few syntactic issues with this program, but this is the main. This though, if we fix the syntax errors, this would be our S. That's the body. So that whole thing is S. And so what did I do? I said down here, look, after the substitution into the body of find sum, if we take term, and term, you see, is the name of the form parameter, and it occurs here. So what we do is we look and we get back. This bit of code here is the body of find sum where term has been replaced by I times I. And so now you can, evaluate this program. You go like, okay, high is 10, temp is 0. While not and you have to look back up further in the code up here and see that, okay, I was equal to low, which was equal to 1. So we start off with I equal to 1, and while I is not greater than high, we begin and we say, okay, temp, which starts out as 0, temp plus I times I, which is 1 times 1, so we get 1. And then we increment I, and then we come back around, and we've got I is equal to 2, and now we've got temp is equal to 1, and so temp plus I times I is 1 plus 4, and so forth. So this computes this. And it's because we substituted in a kind of a complex A expression into the call here, and then that gets expanded, and it kind of gives us our f, our function of I. Okay, I don't know. I mean, I'm going to give you some code for this that, writing, it's kind of boilerplate code. If you look at the definitions for the var and for the declarations are where it gets a little tricky. For the var and the proc case are the two cases where something interesting happens. And one of the things that you need is you need a way of getting a fresh variable. And to do that, that means you have to, there's all kinds of ways to deal with this, but you have to write code that passes around all the variables that you've seen so far to every call. And, you can take a look at that code when I put it up, so to see if you want to take a look at it. Okay, well, thank you for listening. Hope you're hanging in there, not too lonely. All right, bye.